Now, a race car covers distance 8.8 kilometers from rest to rest. So that's 8,800 meters. It accelerates uniformly in the first minute for 60 seconds to a maximum speed of 40. It holds the speed for a certain time and then slows uniformly to rest with a retardation of magnitude 3 times that of the acceleration. Okay, I'm just gonna quickly show you a quick trick and I'm gonna explain it. All right. So imagine this, all right. Imagine for argument's sake, I need numbers 4, 12, 60, all right? Imagine a U value of 60 and a U value of 0, a V value of 60, and an A value of 4. You happy with that? Now, imagine this, right? V equals U plus AT. Next, imagine 60 equals 0 plus 4A. Is that right? 4A? Go with that? And then, sorry, 4T, not 4A, 4T. Everybody happy with T equals 15 seconds? Yeah? Now, what would happen if we tripled the acceleration? What do you expect to happen to the T value? 1/3. The faster you accelerate, the less time you spend accelerating to reach your top speed. So example is, if I triple A, and see the way in this question we're going to triple for our deceleration. Okay, so even if I make that for argument's sake 12, yeah, and this is now 12T. What's T now? T will be 5. Tripling the acceleration or deceleration 1/3 the time. Is that right? Just so we're all familiar with that trick. It's an important trick when you're doing this. Okay, so let's draw a rough speed time diagram. Okay, do we start off at 0, 0? How do I know we start off at 0, 0? Rest, okay? We go here. And we go up like that, okay? Then what happens? We hold it at 40. And then what happens? The second triangle, will it be steeper or shallower? Was it steeper? Yeah, 3 times exactly. So this okay, so I just slanted, isn't it? There we go. Now, see that green time? This blue time here is 3 times the length of the green one. Agreed? It's 3 times longer because its acceleration is 3 times smaller. So if I make the green one T, what should this one be then? 3T, shouldn't it? Because it takes longer. All right, what else do I have then? We agree that's 40. Okay, so does it give me my total time? Oh, right. Tells you what the first part is. It says the acceleration is. It says 60 seconds. So what does that mean 3T equals? So what does that mean? T equals 20. So everybody happy that's 60 and that's 20? You cool with that? Now, because I don't need to use T anymore, I'm just going to get rid of it. And now I'm going to call the middle section T. Is that right with you guys? Now, we're going to get the total area of this. So what's the area of the first triangle? It's a half 60 times. Yeah, it is 1,200. Good man. And then the part at the end, a half 20 times 40, which is 400. Okay. And then the middle part, 40 times T. 40T, isn't it? Not. Yeah, no, yeah, give me a sec. I'll get there. Okay. So, see the 8,800? Yeah. So the way I'm going to, you are right, you're just a little fast for me as well. So the 8,800 equals the three areas added together. That's your 1200, your 40T, and your, what's that, 400? And as Toby rightfully said, he brought them over and took them away. And he said that's 7,200 for the 40T. Divided by 40, and what do we get? Anybody? T equals 18? 180? 180. 180 seconds for the full time. Have I answered the question? I have, haven't I? And I'm hoping the video was something similar, if not clearer. Okay. Now, part 2 was the part that we had to bother with, was it? Okay, so let's have a look at part 2. Okay, and I'll just get rid of this. Now, part 2. The maximum speed over the final kilometer of the journey, had it been restricted, if it had been restricted to 20 meters per second, show that the time taken from rest to rest would have been at least 22.5 seconds longer. Okay. Rest to rest, final kilometer. Okay. Let's think about it. Would everybody agree final kilometer obviously is the final 1,000 meters? Yeah. And if you look at this section here, so see that 400? Yeah. And you're gonna have to stop somewhere here, aren't you? Because your first 1.2 kilometers is in here. And we said earlier that our middle 7.2 kilometers, our middle 7,200 was here. Okay. But we're going to have to stop at the, what's it, 8.8, isn't it? We're going to have to stop at the 7,800 mark. Do you understand what I mean by that? We're going to have to stop at a total distance of 7,800, and then we're going to have to what's that word? We're going to have to decelerate. So it's a tricky one, all right? So let's start off the same. I don't think that the start is unaffected, isn't it? What do I mean by the start is unaffected? We're still going to go all the way up to 40. And what distance are we going to cover? What? And it still takes a minute to do it, doesn't it? So it's still 60, and it's still 1,200. Okay. Now, can anybody tell me? I'm about to make an error. I'd like somebody to tell me the error I'm about to make. All right. So I'm going to say that I have to bring this as far as 7,800. Does that make sense? So I'd add on an extra 6,200. Now, sorry, 6,600 for this. Can anybody tell me what's the mistake I made there? And then the final kilometer would be the 1,000 meters at the end. Can somebody tell me what the mistake I made was? I've made a mistake. I'm just wondering, can you guys tell me what mistake that is? Yes. I need to incorporate a deceleration from 40 down to 20. Yeah. So I didn't incorporate that is the issue. Okay, so I'm just going to go back here. Okay, now I purposely make errors as a teaching mechanism to show you why you don't do that. So, and then other times I'm just crap, right? But what I'm going to do is I'm going to decelerate from 40 to 20. Does everybody see that? So there I am at 40, and I'm here at 20. Okay, now 20 kilometers, 20 meters per second for the last kilometer, isn't it? We're not allowed to exceed that. Now, once again, I'm going to continue along my way. Then what's going to happen? I'm going to have to decelerate down to 0. And that is going to be it. Now, does it say anything about my deceleration? Same deceleration as last time. So I can't exceed the deceleration from last time. Does that make sense? So I'm going to have to go back to the last diagram. And we're going to have to figure out what the acceleration and deceleration was, particularly the deceleration. So what did we say that was? 40 divided by 60, wasn't it? 40 and 60, so would everybody agree it's the tan of the angle? The slope. 2/3 for the acceleration of that section. And then that was 20 and 40. So that's a deceleration of -2. -2, the deceleration. Okay, so we now know the deceleration of the final region. Okay, now we're going to have to put some numbers on it, which is going to be really fun. Okay, what I'm thinking is, I can work backwards here, and I'm thinking I can get the last section pretty handy. So here's what we're going to do. Actually, yeah, I know what to do here, right? See the 20 down to 0 part? Ever see the 20 down to 0? We know the deceleration is what? 2 meters per second, don't we? So 20 divided by t, would you agree that's the slope? 20 high, t across. And that, I won't put it equal to -2 because that means I'll get a minus time answer. I'll just put it equal to 2. Now what's my t value? Takes 10 seconds to decelerate. You'd get the same answer if you use phi equals u plus at. Everybody on board with that? Okay, it's tricky. So that's 10. Okay, we have that. Okay, I can also do this region in here. See this blue region here? 40 down to 20, isn't it? And see this green height here? What would that be height wise? 20, isn't it? And once again, the slope is -2, isn't it? So what'll be your t value? It's 10 again, because the slope is 2, so 20 over t is 2. That's another 10 seconds right there. You cool with that? Now, okay, what do we have? We have 10. Now I'm going to have to start figuring out some distances for myself, okay? So we have to prove that it's 22.5 seconds longer. Tricky question, right? So let me see. What's the total distance? Huh? 8,800. Oh, we know something. Yes, we have it. We have it. See this yellow section here? What is the value of that yellow section? How do you know it's 1,000? Last kilometer, that's your speed limit, right? So we know that the yellow section is 1,000. Is that okay? Next section I'm after is the blue section here. It's a triangle plus a rectangle. Okay. So what's the size of the triangle? 20 across and 10. Half 20 times 10? 100 meters, like you said. The triangle is 100. What about the bottom part? 10 by 20? 200, isn't it? So the two of them combined are 300. Yellow section is 1,000. Blue section is 300. We already know that the starting triangle, which for argument's sake I will now call the pink section, is how much? What's the only part we're missing? The white rectangle, isn't it? Well, let's take all those numbers away from 8,800 and we can figure out what size that is. So let's 8,800 deduct all of them. And what do we get? What do you reckon? Sorry, brains is 6,300. Awesome. Just give me a second. No, man, just give me 1 second. I think I'm about to get it. I think I'm about to kill this. All right? See the 6,300? All right. I want to find the time I was going in that white rectangle. So it's going to be distance divided by speed. So what's 6,300 divided by 40? There you go. 157.5. Now here's what I want you to do. Add up all the times together. So the times are as follows. 60 for the first section. 157.5 for the section. 10 for the blue section. And, ooh, we didn't get the time for the last section, did we? That's what we're lacking at the moment, isn't it? Okay. It's easy enough to pick up. I'll show you how to do it now. So does everybody understand that I have every time except for this part here? That's the only section I haven't got a time for, yeah? So here's what I'm going to do. See the two yellow bits? What do the two yellow bits add up together again? 1,000, isn't it? And we're going to find the area of the last yellow bit, which is it's a 10 times 20, a half 10 times 20, 100. So if that's 100, then this part must be. And what's 900 divided by 20? Because you're stuck at 20, aren't you? So what's 900 divided by 20? 45. Now, lads, add all these together. See this box here? I want you to add all those numbers together for me. What do we get? It's bigger than that, surely. 2? Just only 2.5? We got 282. Oh, sorry. Shh. Sorry, lads. I forgot to put in the second 10. So 282.5. We killed that. Now, what was the old time? Back when we were here a minute ago. What did we say that middle section was again? Yeah, 180. So it was 260 was the old time, and 282.5 is the new time, and that gives us a 22.5. And that's what we're asked to prove, wasn't it?